For many project managers, quality is hardly the highlight of our profession. You know you need to understand it, and of course you know you need to deliver it, but that hardly makes it a source of excitement. I say you need to put quality at number one. Yup, I want to make an argument that you should be putting quality right at the top of your priority list. And I'm not going to use the familiar arguments that you already know. Arguments like your client, your boss, your organisation are paying for quality. Your reputation is tied to the quality of your deliverables. Poor quality means tedious rework. Right first time saves time and money. Poor quality creates health and safety threats, and low quality can also compromise security. You know all those arguments, you've heard them all before, you've probably even made them. No, I have another reason why you should prioritise quality on your projects. And this one is entirely personal, and it's hard to articulate, but I'll have a go. I do suspect that this is something that you have felt at times, and part of it is the deep pride you feel in doing something well. And that's the easy part to explain. But pride isn't quite what I'm trying to get at. Sometimes there's a deep pleasure in doing something really well. You get lost in your work, and you feel a deep sense of contentment while you're doing it. This makes the work deeply fulfilling. And I suspect this is something around the concept of getting in the flow. That timeless sense you get when you are totally engaged in the work that you're doing. What I am straining to get at is mindfulness. When we dedicate all of our attention, give a deep focus to one thing, and pay complete attention to what's going on, magic can happen. That magic is something about the way we feel, the acuteness of our senses, and a complete confidence in our work. You get so lost in your work that it gives you complete satisfaction. There is nothing more that you want in the moment. It goes beyond pride, even goes beyond flow. And when you've finished, you feel a deep sense of fulfillment from the work that you've done. In this sense, you can put quality first in anything you do, in any project, any part of your project, in any endeavour in your life, be it exceptional or routine. It might be producing a deliverable, dealing with your administration, holding a conversation, or even having your lunch. Turn every last scrap of your attention over to the task in hand and see what a difference it will make. Did you know that there are 3 primary quality processes in project management? It all starts with QD, quality design, designing your solution, your product, your deliverable to the quality standard that is set. Second is quality assurance, QA. Quality assurance is the process by which you assure that you deliver the products or deliverables to the quality standard in the design. Quality assurance is the primary process-driven way of getting the right result. But what if you don't? That's where quality control, QC, comes in. Quality control takes a look at each deliverable and assesses them for quality before releasing them to the world, to the beneficial owner. So quality design is about planning it right, quality assurance is about doing it right, and quality control is about checking that you got it right. Quality management is often seen by project managers as some kind of nice to have extra, rather than as a core competence. Yet it should share equal priority alongside schedule and budget management. I shouldn't need to make the case for quality management, but go on, I will. Paying attention to quality will increase the chances of project success. It will improve your value delivery, increase the reliability and the durability of your project deliverables, ensure conformance with standards, and keep your stakeholders happy. So, what do we mean by quality? There are many aspects of quality, including performance, conformity with standards, reliability, sustainability, durability and resilience, uniformity, satisfaction, efficiency, design, and aesthetics. But there is, of course, a cost. Cost of quality refers to the costs arising from two things. First, the cost of conformance, and second, the cost of non-conformance. The cost of conformance is the money we spend during a project to avoid getting substandard products that don't conform with the specification. This includes the cost of preventing non-conformance, or quality assurance, and the cost of spotting it and putting it right, or quality control. The cost of non-conformance is the money we spend during or after a project dealing with substandard products. These can be pre-release non-conformities found by your project team, sometimes called internal non-conformance, or the post-release costs of problems that are found by your end users, sometimes called external non-conformance. Delivering quality. We deliver quality through four principal processes: quality design, quality assurance, quality control, and quality procurement. Quality design is where we define the quality standards that our products need to achieve, and it's also where we plan how we're going to be delivering quality throughout the whole project. Quality assurance is the set of processes we use during our project to ensure that we meet our quality standards. We often need to align our project activities with our organisation's quality management processes and procedures. Quality control is the set of monitoring and review processes that check that the quality of the products we've created meet the quality standards we've set before we release them to our customers or end users. This includes the remediation procedures for any products that don't meet the quality standards we set in the quality design stage. During quality control, we also maintain excellent record keeping for the results of each quality assessment. Quality contracting is the set of processes we overlay on the procurement process to ensure quality in everything we do in the procurement process. This includes specifying our goods and services with care, selecting the right suppliers, building good working relationships, and actively managing the contracts accurately and precisely. Quality management plan. You'll also need a plan that sets out how you will ensure that your deliverables meet the specifications set out in your quality design documents. I recommend that your quality plan covers 7 things: the quality expectations of your stakeholders, the criteria against which quality will be assessed, the quality standards you'll work to, quality assurance procedures, quality control procedures, your change control process, and the responsibilities of team members for all of the above. These 7 things represent the sections of our quality plan template. This is one of over 50 project management templates in our Project Management Templates kit, and I'll put a link to it in the description. A culture of quality. The soul of quality assurance is a culture that values quality. This is one where everyone knows the importance of quality to the project, and each team member has a true commitment to every deliverable meeting its specifications. Because prevention is better than cure, quality assurance is all about getting it right first time. Quality control, of course, is about catching it when you don't. That is to say, quality assurance processes can never guarantee quality. What they do is they create a framework which makes quality easier to achieve and to assure. But it's only when people follow the processes that quality can be assured. Your QA process is likely to touch on a number of things: the sourcing and procurement of components, the operation and maintenance of equipment, checking and testing during development and product creation, reporting and recording of data, and auditing and reviewing the processes. And of course, you need to tailor your project's quality assurance processes to fit in with your organisation's own quality management and quality auditing procedures. And of course, for long projects, we should be aiming for continuous improvement of all of our processes and procedures, including our quality processes. To conclude, I have produced a summary chart of all of the quality processes in project management. You can download it for free, or you can make a small donation to contribute to the channel from the link in the description. Quality assurance is pivotal to making sure that project deliverables meet the predefined quality standards and stakeholder expectations. In this video, we'll look at QA in project management and also the application of the Plan, Do, Check, Act framework for continuous improvement. Effective management of quality assurance not only reduces the level of risk in our projects, it also increases project success rates, improves team morale, and enhances stakeholder appreciation for the work that we do. In project management, quality assurance refers to the processes that we design to ensure that the deliverables we produce meet the quality standards that we've agreed to. It involves planning, executing, and monitoring the process throughout the project lifecycle. Unlike quality control, which focuses on detecting and rectifying defects, quality assurance is a proactive approach to try to make sure that we don't have any defects in the first place. It's all about adherence to predefined quality criteria and prevention of mistakes. Quality assurance starts with setting clear quality objectives. At the outset of our project, we need to set quality objectives that line up well with our other project objectives and with our project goal and purpose. It helps to use something like the SMART framework to make sure that our objectives are specific, measurable, agreed, relevant, and time-bound. And of course, since it's your stakeholders who will ultimately assess your project outcomes, you need to be involving them in determining your quality objectives. This fosters an alignment around the project requirements and also a sense of ownership and responsibility among your stakeholders. Next, we need to build a robust quality assurance team. If you're going to implement quality assurance effectively, you need a strong team able to do that. you need to define clear roles and responsibility that ensure accountability, but also foster collaboration among team members. And of course, if you can cultivate a culture of quality within your wider project team, you will improve on things like problem solving, knowledge sharing, and continuous improvement, not to mention a pride in the quality of the work that we're doing. Third, we need to implement effective quality assurance processes. These are in many ways the backbone of effective project management. We base them on the plan, do, check, act cycle, sometimes known as the PDCA cycle, the Deming cycle, or the Shewhart cycle. Planning entails defining the QA standards that we're going to work to, establishing our quality assurance procedures, and allocating resources into the QA function. Execution, the do, involves implementing the QA process and monitoring the quality of the products that come out as a result. Checking entails evaluating your project performance and your QA performance against the standards that you've set. And acting involves implementing corrective actions that you draw from the lessons learned from the plan, do, check, act cycle. The result should be a more streamlined QA process and improved project quality as you go forward. Fourth, we need to think about ensuring compliance with standards and regulations. In many projects, you will find an imperative to comply with industry standards, regulation, legal requirements, or indeed company policy and procedure. And of course, let's not forget that many projects are delivered by external organisations working for a client. The client specification provides the ultimate guide to the standards you need to meet. You need to build these compliance standards into your QA processes and procedures. Fifth, we'll sometimes need to conduct comprehensive quality audits. We use regular audits to verify compliance and mitigate the risks of non-compliance, to evaluate project performance and identify the scope for improving performance, and ultimately to ensure that we meet our quality standards. This is of course a core part of your project governance, but it will also build trust among your stakeholders, your users, or your customers. Audits should go on through all project phases, right from the very start through to the closing of a project. The purpose of them, of course, is to create early detection of problems with your quality assurance processes. You should always document your audit findings, and if there are corrective actions to be taken, take them as quickly as possible. Ideally, you want to build a shared accountability amongst your team for the continuous improvement of your project, and a culture that sees audits as something there to help rather than a threat to the project team. Finally, we need to emphasise continuous improvement through the plan, do, check and act cycle. PDCA is a framework for continuous improvement. If you're not using it on your project, then there is a real chance that you will embed procedures, processes that quickly become out of date and inefficient. PDCA allows us to check on how we are doing and to make corrective actions so that each increment of our project takes us forward to better, more effective, more efficient processes. To conclude then, mastering quality assurance in project management requires that we set clear quality objectives, have robust processes and strong stakeholder engagement, and pay constant attention to the possibility of continuous improvement using the PDCA cycle. Quality is important in itself, but good quality assurance goes further. It mitigates risks and it builds confidence. Ultimately, our job as project managers is to deliver to specifications and, if possible, to exceed our stakeholder expectations. Embracing a culture of quality and continuous improvement allows project teams to adapt to the constant change we face in a dynamic project environment. It allows them to innovate and therefore to excel in the delivery of our projects. In this video, we're going to look at the software testing process, and I'm going to answer the question, what is user acceptance testing? There are many types of software testing, and each project manager, product manager, software engineer is going to select different testing types to suit the needs of their product and their project and the culture within which they're working. Now, I am not a testing manager and I am not a software engineer, so I do not have expertise in this area. So this video is designed for generalist project managers who want an overview of software testing and not for specialists who need to understand it in any depth. We're going to take an overall survey and look at what for many is the most important level of software testing the user acceptance test is all about. There are 4 main levels of software testing, and the first is component or unit testing. And as its name suggests, this is all about testing individual components to make sure they work as designed on their own. The second type of testing is integration testing, and this is where we put components together in logical groupings or chains to make sure they continue to work as expected when connected up to other existing or new components. Third is system testing. This is when we put all of the components, the new and the pre-existing components together to form the full system that will be operating, and we test it to make sure the whole thing works properly. Finally, we have user testing, where we expose the system to the users. And the final tier of that is user acceptance testing, where our users test the system with the intention of determining whether it is usable and therefore whether they will accept it. It is the last barrier before a new system is put into live operation. The problem with testing by experts is that they tend to know how the system, the product, the software that you're creating is supposed to work, and therefore they have to work particularly hard to do stupid things. Users, on the other hand, don't know what you're expecting them to do, so they will do what seems natural. Therefore, if you've not properly anticipated the way that users will use the system, users are far more likely to find the faults in your design or your implementation. The main purpose of user acceptance testing is to validate the new software against the business requirements. And of course, it's the end users who are most familiar with those business requirements. So, user acceptance testing is the last opportunity for your customers to test the software and to validate that it is fit for purpose, that it meets the business requirements. So, this gives us a working definition for user acceptance testing, or end user testing. It's testing by a user or client or customer to determine whether a fully functioning product is acceptable or not. As a result, it is the last obstacle for a new piece of software to pass before it can go live. Every test manager will have her or his own detailed process or variant on the process for user acceptance testing. However, these 7 steps are indicative of how user acceptance testing is carried out in a wide range of circumstances. First, we analyze the business requirements, and second, we create a user acceptance test plan. Then, we identify realistic test scenarios, and then fourth, from these, we create the user acceptance test cases. then we need to prepare test data that as closely as possible mimics real-life production data. Step 6 is where we run the user acceptance tests and record the results. And finally, at step 7, we confirm the compliance with the business requirements. Now, many non-specialists will have heard the term beta testing and possibly alpha testing too, and even if you've never heard of alpha testing, the very existence of beta testing suggests there must be an alpha test. So how do alpha and beta testing differ from one another and from user acceptance tests? Alpha and beta testing are primarily about rooting out the very last bugs in a tested software product. They do this in a real user environment to give the development team the closest possible understanding of how their software will perform in the real world. Alpha testing is a form of internal acceptance testing. It can either be the final stage of a system test or the first stage of a user test. In the first case, where alpha testing is the last part of systems testing, it's usually carried out by the software quality assurance or testing teams. They're looking for the final bugs that they can remove before exposing it to real users. However, alpha testing can also be done by real users in a real situation. However, when real users find bugs in an alpha testing context, then they will be reporting them confidentially to the development team, and they will be fixed before moving to the beta test stage. Beta testing follows alpha testing. And beta testing is the final stage of testing before the user acceptance test, and it is testing by users in a real-world environment. The difference is that user acceptance testing is all about the user determining finally whether the product can be accepted or not, whereas beta testing is allowing the users to use the product in a real environment to find the very last flaws and faults and bugs before the product is exposed to the final user acceptance test. So, to conclude, user acceptance testing is not about finding bugs, as alpha testing and beta testing are. User acceptance testing is verifying that there are no more important bugs to be found and that the product is ready for the live environment. Once the user acceptance test is complete, the team will get sign-off for the go live. Please do give this video a like if you've enjoyed it or learned from it. I'll be creating loads more great project management content for you, so please do subscribe to the channel and hit the notification bell so you don't miss any of it. And I'll look forward to seeing you in the next video.